Greetings learners, I am Dr. R.S. Sugashwar Prashant, Assistant Professor, School of Management Studies, Villupuram Regional Center, Tamil Nadu Open University. In today's sessions, we will be discussing about information system for managers. In this information system for managers, we will be discussing about database management system and then distributed system. Okay. The database management system is an file organizing or an arranging the centralized data and managing those files efficiently and providing access to the stored data by application programs. See, an organization collects the data of an employers, and they store in a particular system in an order. Okay. Each data will be collected as per the record maintained for each employee and employer. Okay. The DBMS actually acts as an interface between the application program and the physical data files. Okay. When the application program calls for a data item such as gross pay, the DBMS finds the item in the database and present to the application program. Okay. The DBMS relieves the programmer or end user from the task of understanding how the data actually is provided, either logical or physical views of the data. The logical view represents the data they would present by the end user, and the physical data shows how data are actually organized and structured on a physical storage. See, database management system generally organizes each and every data of either employer or employees. Even the consumer data is managed in the database management system. The files which are been organized can be taken at any point of time. Okay, at any point of time, whenever the end user asks for a particular data, for example, and by typing the employee number, they can take the complete details of an employee, or else if you need a medical certificate of an employee, you can take from the database management system. That is how the files and data and records has been kept in the database management system. This is an actual overview of a database management systems where actually access to files is being there. Okay. The next thing is, here is how the database management system actually works. Okay, for an example, if an employee has a file of data, okay, like his name and SSN, position, and the date when he has been hired, and his gross pay, net pay, life insurance, pension benefit, healthcare. Okay, the database management systems, when I am I need an employee's payroll view, the exact details or file or records of his name, SSN number, gross pay and net pay will be showing to the end user. As well as when I want to view just the benefits of an employee, his name will be viewing and his SSN and his healthcare. That is how the database management system will be showing the exact data of an employee. The next one is the Relational DBMS, Relational Database Management System. The contemporary DBMS use different database models to keep track of entities, attributes, and relationships. The most popular type of DBMS today is for PCs or for larger computers and mainframe is the Relational DBMS. The Relational DBMS represents data as a two-dimensional tables called relations. Tables may be referred as files. Each table contains data on entity and its attributes. Okay. Microsoft Access is a relational database management system for a desktop system, whereas DB2, Oracle Database, and Microsoft SQL Server or relational DBMS for large mainframes and mid-range computers. MySQL is a popular open source DBMS, and Oracle Database Lite is a DBMS for small handheld computing devices. In the relational DBMS, you actually need to understand that most of the files, huge files for an organizations or a large industry or a multinational company uses this SQL server kind of a thing for their organizations in order to store many entries as possible, many files and data as possible in the relational database management system. Okay, and MySQL is also a popular open source DBMS, and Oracle Database Lite is another used for small handheld computing devices. Okay, so relational DBMS is an two-dimensional tables. Okay, and here it is, each table will be containing an entity and attributes. These tables might be referred as files. Okay, the next thing here is an file which we are going to see with an example. Okay, here the upper table, which consists of uh, the with the attributes and fields, you can see the supplier names, sorry, supplier number, supplier name, supplier street, supplier city, and supplier state, and supplier zip. Okay, those are the rows, records, or tuples. Okay, the supplier number, which is also called as primary key, or it is a key field which is a primary key. This primary key will be having a unique number ID. Okay, you cannot duplicate this primary key field. For an example, the first row, you can see that it is 8259. You cannot find the 8259 again in anywhere else. Even if it is a more than 500 number of list of supplier numbers, the 8259 will not be repeating. It is an unique supplier number which has been given to a particular supplier name like CBM incorporate. Okay, the next, it is a part. Okay, the next one is the part. Okay, in the second diagram below, which is the part, you can see this, there is a part number, and then part name, unit price, and supplier number. Here in this part, you can see this, the part number is called primary key, and then supplier number is called foreign key. As in this table, you can see this, there cannot be in this primary key, there cannot be a duplicate number repeating again. For example, 145 cannot be repeating again, so it is a primary key. As well as from the above diagram, we can clearly say that the supplier number is also unique, which cannot be repeated again. Okay, so here what I am going to here, as you can see, the supplier number is mentioned as foreign key, whereas which actually tells that it is an unique ID. Okay, so it is a unique ID, so it is actually mentioned as the foreign key. In a particular part of the database management file, there can be only one primary key, and there can be another file with an unique numbers, which from the above figure you can say it as a foreign key. Okay, so here the actual information about a single supplier that resides in a table is called a row. Rows are commonly referred as records, or in technical terms as tuples. Okay, and data for the entry part have their own separate table. Okay, the field for supplier number in the supplier table uniquely identify each record, so that record can be retrieved, updated, or sorted, and it is called key field. Each table in relation database has one field that is designated as primary key. As we said, there can be only one primary key in a key field table or in the tuples. Okay, the key field is the unique identifier for all the information in any row of the table, and the primary keys cannot be duplicated. Okay, in the supplier table, supplier is the part where the field supplier number appears in the part 2, and the key foreign key, and is essentially is a field to look up to the specific part in the supplier table. Okay, so it is mentioned as the supplier table will be having a foreign key to look apart in the uh, previous figure, like primary key. Okay, so the next, here you can see that the part and supplier are two different and files, or it's called as tuples. Okay, here we are going to select a number at the below of the part table. You can see that select a part number 137 or 150. When you are seeing from the part table as well as from the supplier table, you can see that the part number is 137 and 150, and the supplier name is the CBM incorporate, and as well as Jackson components, okay, which are the part number of 137 or 150. So when you're asking for a particular, as an end user, when you're asking for a particular part number, okay, you need, and for an example, if you need a door knock, uh, sorry, door lock, you need to click number, part number 152 will be coming up. Okay, if you are clicking up 178, the door handle part number will be coming up. For the door handle, if there is an kind of an supplier, his name will be coming here with the supplier number. Okay, so that is what the DBMS actually works. Okay, when as a user you require for a particular part number, you enter those numbers in the field to search the file or a particular supplier name. You enter just the part number like 150. Automatically it mentions the door molding. Okay, and automatically it comes with the supplier number and as well as Jackson components. Okay, here we can tell us part number as an primary key and supplier number as an foreign key. Okay, so this is how the database management systems, when you search for a file, it actually works. Okay, the next one is the object oriented DBMS. Many applications today and in the future requires database that can store and retrieve not only structured numbers and characters but also drawing, images, photographs, voice and full motion video. DBMS designing for organization data into rows and columns are not well suited in handling graphics based on multimedia applications. Object-oriented databases and suited for this purpose. An object-oriented database management system stores the data procedures that act on those data as objects that can be automatically retrieved and shared. Object-oriented database management systems are becoming popular because they can be used to manage various multimedia components or Java plans used in web applications, which typically integrate piece of information from a variety of sources. Okay, so although object-oriented databases can store more complex types of information than relational databases, they are relatively similar to the relational database for processing large numbers of data. Hybrid object relational databases are now available capabilities of both object-oriented as well as relational DBMS. Okay, so the object since in this slide we can see that the object-oriented DBMS is actually telling about it is type of handling drawings, images, photographs, voice, and full motion videos. When an organization uses object-oriented DBMS, it automatically it carries a large number of storage capacity the organization is needed. Okay, so when this kind of a files is generally used for a web applications or a software to compile or to compile. Okay, so uh, it is stating in relational database data as well as the object-oriented database management systems. Okay, in the hybrid object relational database management systems, which is where actually both the relational and object-oriented database management systems are functioning in a very similar way, in a much capabilities working in a smooth way. Okay, and there is a cloud database which actually suppose if your company wants to use a cloud computing service, there is the way to manage in the cloud. The answer is yes. Cloud computing provides offer database management services, but these services typically have less functionality than their own premises counterparts. At the moment, the primary customer base or cloud-based database consists of web-focused startups or small, medium sized businesses looking for database capabilities at a lower price than the standard relational database management system. Okay, there are a few companies like Microsoft and Amazon. They give both a simple database or a relational database service to the small size companies and medium sized businesses. Okay, usually when you are starting in company, when you are starting in like a company related to information technological field, you need to store a lot of databases. Okay, you cannot actually own those kind of hardware equipments at initial cost because the capital budgeting will be more. So that what actually some initial startup companies or medium based companies do that, they actually go for an outside services, okay, like rent based cloud services from other companies like Amazon or Microsoft, okay. They charge for a particular kind of an monthly premium amount, okay. And as I said, cloud database, it's not functional completely, like it is under your premises. It is like not, you are not owning the complete storage spaces. You might be given access to those files, and you can access through the internet to those files and access them, and keep back in the database server itself. And if you need to change some of the main modifications, you need to ask, you need to have some kind of a premium kind of subscription to change some of the databases. So that is the one of the disadvantages in the cloud database. But for a startup or medium sized businesses, cloud database is one of the best option at the initial time. But eventually, if they are capable of owning and hardware technology related to building up their own databases, file systems in their own premises, it will be much suited for them to run the uh, to run their organization in a more efficient way. Okay, but databases is in today's field of view, it is more commonly in many IT fields, and many startups are using the cloud database to make their productivity much faster, and as well as more reliable, as well as the companies, those who are providing those cloud database management systems for the other companies, they are also giving at a very good premium prices, and the market is they are giving the premium services to those new startup companies, and they are making available for like 24/7 at any time, when the clients, the customers, those startups who are requiring for the cloud database, they are ready to give them services 24/7, which actually will be increasing the premium cost for the end user. And this is an Microsoft Access Data Dictionary features. And here also you can see that there is an if you are seeing the supplier details, like the field name, data type, and description. The in the supplier number, you can see that is the auto number, supplier identification number, and then the supplier name, the data type, which is actually text, or if it is a number, it will be changing. We can change those kind of an options. If you at the bottom of this supplier zip, you can see it has been mentioned as text. Actually, the zip codes, or like pin codes, it will be actually as a numbers. You can change those data type into numbers, and so that Microsoft Access use a relational database management systems in a more efficient way to their consumer as well as the individuals. Okay, and here is the same kind of an the example figure which we have seen before. Like we like to see a particular number, part number like 137 or 150. When you are clicking it, it will be taking the file from the database management systems, and it will be giving you the access query, and you can when you are requesting for the particular data, it will be coming up. Okay, and this kind of an uh, Microsoft Access is an older preview of data. Okay, it is an older preview of data. So nowadays it has been updated with the latest version of the software. Okay, it is much more technologically advanced. Okay, and the next thing is non-relational database. Okay, see, non-relation database is an different from the traditional relation database, in which they store their data in a non-tabular form. Okay, in database, we used to store everything in an data form, which is actually in an table format. Okay, like there will be an every supplier name and data will be organized in a neat way. Okay, but here it will be these data structures in the non-relation database. It will be like in documents. Okay, it will be a document with a highly detailed while containing a range of different types of informations in different formats. Okay, this ability to digest and organize various types of information side by side makes non-relation database much more flexible than relational databases. Okay, see, as we said, this non-relational databases are totally different from the relational database. Okay, and this non-relation database uses large quantities of complex and diverse data to be organized. For example, here a large store might have a database in which each customer has their own document containing all of the information from name to address to order history and credit card information. Despite their differing format, each of this piece of information can be stored in the same document. They don't need to be in different documents. Okay, and non-relational databases often perform faster because a query doesn't have to view several tables in order to deliver an answer as relation data sets often do. Non-relation databases are therefore ideal for storing data that may be changed frequently. For applications that handle many different kinds of data, they can support rapidly developing applications requiring a dynamic database to change quickly and accommodate large amounts of complex and structured data. See, the non-relation database, you need to understand that when you are searching for a particular supplier or a supplier name or a customer ID, okay, you don't need to go through all this tabular columns. You don't need to go through all your customers. Okay, if you are having like 5,000 customers, when you are searching on the relational database management system, you need to go through all the files which are in the relational database. But whereas in a non-relational database, since it is a documents type of a structure, it directly goes to the concerned customer and takes his address or the billing history or whichever you need. So non-relational database is a much faster way of getting things done. Okay, and there are these are the benefits of the non-relational database. It has a massive data set organization, flexible database expansion, and multiple data structures, and it is also built for cloud. Okay, and in the as we said, massive data set organizations. Non-relational databases can not only store massive quantities of information, but they can also query these data sets with ease. Scale and speed are crucial advantage of non-relational databases. And there is flexible database expansion as more information is collected, and non-relational database can observe these new data points, enriching the existing database with new level of granular value, even if they don't fit the data types of previously existing informations. And multiple data structures, the data now collected from user to takes on myriad of forms, from numbers and strings of to photo and video content to message histories and every kind of informations which you can add on multiple data structures. Okay, like yearly wise data or images, any kind of things can be built. And as well as a non-relational database can be massive. They can some is grown and expensive and hosting environment that grow and expand with clouds, cloud space, and you can also use the non-relation database with the cloud database. Okay, and as well as you can relate with the non-relational databases with an application development, whereas applications must be able to query data efficiently and deliver results most instantly, and non-relational databases are a natural choice for this kind of an environment. They offer both security and agility, allowing for rapid development of applications in an agile environment, easier and less complex to manage them. Relational databases, they also yield lower data and management costs while providing superior performance and speed. Okay, naturals for agile development. Non-regional databases can accommodate the complexity of inputs more effectively than structured databases. See, Then, and when an application is interlinked with the non-relation databases, it can access much faster, quicker data which is actually needed. For example, if you are on a like online shopping applications like Amazon or Flipkart or any Zomato, Swiggy, this kind of an application uses this kind of an database management system. Whenever you search for a particular locations, the different kind of results you will be getting. If you are in northern southern part of India, or in any other states in India, based on the cities and the rural areas, the locations, and based on the culture, the dress, or whichever the product you are searching on their applications, based on the non-relation databases, it might be changing as, and it might be fast as useful, and as well as they might be using a cloud storage of databases which can give you the information at any instant point. So that is what the application development is mostly is about, how faster this kind of a system can actually give the data to their end consumer whenever the database management system is ready to try to give you this selected end user file which actually the user is asking for. Okay, and the next topic is the distributed system. See, the distributed system is completely a computing environment in various components or spread across multiple computers on an internet network. This device splits up the work, coordinating with the efforts to complete the job more efficiently than a single device has been responsible for that. See, distributed system is a particular task has been split into two devices or more. Okay, for an example, if a company has a single database or a single server, okay, and there are 100 employees working on the same server, the server might be going fast. But if there are like 500 employees working on the same server, the server might be going down, and it it actually takes time to load the information that actually the employees are seeking for. So in those cases, the distributed system plays a major role with actually majority of the splitting up the system spaces for the particular task which needs to be completed. When an organization has a different kinds of department, and each department might be having a different kind of a task to be completed or a goal to be completed, these distributed systems are an important development for the IT and computer science, as an increasing number of related jobs are so massive and complex that it would be impossible for a single computer to handle them alone. So that this distributed computing is taken additional advantage over traditional environments. Distributed systems reduce the risk with having single point of failure and bolstering reliability and fault tolerance. And this modern distributed system are generally designed to scalable near real time, and as well as the employees might be working from anywhere, any part of the world. Okay, with real time of action, it is actually with the internet connectivity, you can access the real time processing speed and much more access to the work. And as well as during this pandemic period, we know that the work from home is a kind of a thing which is more popular nowadays. Okay, and as well as when an employee doesn't need to have an high-end configuration laptop to access to work from home. He can have an basic configuration that runs the applications, where distributed system will be performing in the back on the server on the network side, which will be performing much faster than his home system hardware, which is not capable of running in high-end applications. But the network and the server which could handle with the distributed system, so that it will be much useful for the employees to work from home. Or this distributed system is simultaneously the task of different group members from different parts of the world can work towards it at the same time. And as well as it can also be separated for each and every device. When you have a company like globally, your company has been placed like companies like Apple or Sony or Samsung. Okay, this distribution system plays a major role. Or even if your company is a multinational company, in those part also this distribution system plays a major role. Okay, and it is not about it's a big company or small company. Distributed system is generally is splitting up your part of the task, capable of handling multiple system at the same time. Okay, and distributed systems has evolved over time, but today most common implementations are largely designed over the internet and more specifically the cloud. And as we discussed, this distributed systems can be accessed through the internet and cloud system. As I said, if, even though your system is not capable of running at full capacity, actually you might be having an two generation old Intel processor or some old processor with minimum storage of like 500 GB or 256 GB, but you need to access your company files. Okay, you can directly log into your applications, and server will be keep running for you uh, with a real time no errors, and actually you can quickly complete your works on real time, and it doesn't need those high end hardwares to work on your system for those kind of an service based or so company based workloads. You don't need those high end configuration or any kind of things. Okay, so this kind of an distributed system make those all kind of in an easy way. Okay, and also this process continues completed in the complete frame of work, and it can be any kind of related job, like if you are doing a video rendering, or if you are putting up a huge project file, or if you are collecting a data of documents, or collection of say your profit, your sales, your accounting figures, or sales numbers, or your logistics data. Any kind of data can be used in the distributed systems, which we have seen here. And there are some of the benefits in this distributed system, like it has a greater flexibility. It is easy to add computing power, and as the need services grows, in most cases today you can add services to the distributed system on the fly. Okay, as I said, this if you need adding power, you can generally adding power. If one of the department uh, if one of the department is not working, you can use the you can transfer this distributed system to the other department, which actually need those more power to their systems. You can transfer it. That is the greater flexibility and reliability. It is a well designed distributed system can withstand failures in one or more of its nodes without severely impacting performance. In a monolithic system, the entire application goes down if the servers goes down. Okay, then there is an enhanced piece. Heavy traffic can bog down single service. When traffic gets heavy, impacting performance for everyone. The scalability of distributed database and other distributed systems makes them easier to maintain, also sustain high performance level. And then there is a geo distribution content delivery, both initiative for any international or global organizations. As we discussed, it is one of the distributed system is one of the easily handleable, and it makes the work more efficient, and also it gives the productivity to anywhere around the globe, across the globe. And that is the one of the important thing about the distributed systems. Okay, and finally, thank you all the learners for the wonderful session. And if you're having any doubts, you can contact me anytime. And thank you all.